find the domain of the log base 5 of 2x minus 1 over 3x plus 2. So if you remember what you're taking the log of, this does have a name if you watched my videos. It's called the argument. The argument must be positive, which means that 2x minus 1 over 3x plus 2 must be positive. Now this goes back to chapter 3, section 6, where we basically looked at finding the x-intercepts. That's where the numerator is 0. That says 2x equals 1, or x equals 1/2. This is multiplicity 1, so there's no change. And then you find domain restrictions. That's the not equal, or the denominator. So that's where 3x plus 2 can't be 0. 3x can't be negative 2, or x can't be negative 2/3. Then we move to the number line, which would give me negative 2/3 and 1/2. And they change across. Pull a test point, and I'm going to choose my favorite, which is x equals 0. So 2 times 0 minus 1 over 3 times 0 plus 2. That's going to be a negative number. Change positive, change positive. And so this is my outside. So in this case, my answer is minus infinity, negative 2/3, 1/2, infinity. Write as a single log using the properties of logarithms. First thing I need to do is I need to bring the exponents up. So I end up with log base b of x squared plus log base b of y cubed minus log base b of z. First thing I want to do is bring these two together under the property of logarithms, which says if I have a sum, it turns into a product. So this is log base b of x squared y cubed, subtract log base b of, this should be 1/2, z to the 1/2. Now these get brought together using properties of log. This says if I have a difference, turns into a quotient. So this then, my final answer is log base b, and it's going to be this whole big thing. The numerator is x squared y cubed. The denominator is z to the 1/2. Really don't have to do anything more with it at this point in time. Now on this problem, you're going to do the exact opposite, and you're going to break it apart. Well, if I look at that numerator, that's the fourth root. Fourth root is going to be that whole thing to the 1/4 power. So I'm going to first rewrite this as the log of x cubed y squared to the 1/4 power, which is what fourth root is. And then that's going to be all over z squared. Now, properties of logarithm says that if you have a quotient, you can turn it into a subtraction. So this becomes the log of the numerator, subtract the log of the denominator. I can now bring the exponents down, so this would be 1/4 log of x cubed y squared subtract 2 log z. We're not done because we have an x cubed y squared. So now this is 1/4 times, this is going to get broken apart into 2 pieces. This is going to be the log of x cubed plus the log of y squared minus 2 log of z. And I don't need this bracket here. I can't do 2 things at once. And now I can bring these exponents, need to be brought down in front. So this becomes 1/4 times 3 log of x plus 2 log of y minus 2 log of z. And that could be my final answer. Some of you had other iterations of this, but that would be fine all by itself.